Hey, I'm Craik from the Android Framework team.
My name is Yigit. I also work in the Android Framework team. And today we are going to talk about how to handle large lists with paging and RecyclerView. Now, list UI is a very common thing in Android applications. Pretty much every single app has a list of something they want to display. So if you're using architecture components, let's see how you would model a list like this. So you'll have a view model where you keep the list of items so that it survives configuration change. You'll put your data into database so that your application works offline. And of course, you have some server-side component where you pull the data from. But usually, data is dynamic. It changes. So to handle these changes, you would ask database to return you a live data of list of things or an Java observable list of things so that you can handle the updates. For instance, if you pull the updated version of 2 records from your database and you insert it, and then Room realizes, oh, there's a query observing this table, let me rebuild the result, paste it over to the V model, and then your UI can pull from the V model and update itself with the correct animations. This looks cool, but there is actually a problem here. There's something we don't like. To better understand the issue, let's look at the interaction between the database and the UI. So when I mentioned that database is going to rebuild the result, it is going to rebuild all of the results. So if you ask for the users ordered by their last name, and if you have 10,000 users, it's going to create 10,000 users, pass it over to the UI, and it's very inefficient because user only sees like 8 to 10 items. Why would you create 10,000 items? So we don't like it. We want to change this. So what are we looking for here? First, we like that convenience. It's so nice to tell the database, give me a live data of list of users. We want the same convenience. We wanted to handle multiple layers. We want to be able to bring data from the server, put it in the database, and put it in the UI. And this should be very easy to implement. We want it to be fast. We don't want it to do any unnecessary work. We don't want it to do any big chunk of work in the UI thread. It should be efficient. We want it to be lifecycle aware. So if user is not looking at the screen, it shouldn't do any work. Last but not least, we want it to be flexible. Everybody has their different backend APIs, different data structures. Our solution should work with all of these things. Now, if we go back to our first example, how do we implement these lists if we don't use paging? Now, if you're using Room, in your DAO, you specify your query, you tell it to return a live data of list of users. Then you, in your view model, you hold a reference to it and serve it to your UI. In your activity, you would use this list adapter class. But if you're not following our releases closely, you may not heard about it. Let's focus on that one. So list adapter is a RecyclerView adapter that displays a list. So if you have the RecyclerView on the right, when you call the submitList method on the adapter, it just displays it. The nice thing is, if you call the same submitList method with a different list, it's going to calculate the difference between these 2 lists on a background thread and update the UI with the correct animations. It's available in RecyclerView 27.1, and the same functionality also exists in the async list differ class if you cannot extend the adapter. OK, let's go back to our example. We have our adapter. We observe the live data. We send the list to the adapter. So when we initialize our adapter, we need to give it a callback. This does 2 functionalities. First one, it can check if 2 items are equal identically. And the other one checks whether their contents are equal or not, so we can decide whether we need to rebind those views or not. Once you have that in your onBindViewHolder method, you can call the getItem function, obtain the item in the list, and do whatever you want with it. Super simple.
All right, so we've seen what that looks like with the live data of list, but you also started out with, this isn't good enough. So let's look at what this looks like when you're using the new paging library. So first of all, the most important component of the paging library is the paged lists. And this is a list that implements the list interface, but it loads data in pages asynchronously. It's backed by a class called a data source that provides data as the page list needs it, swaps it in, and updates the list. So this serves as a replacement for the list in all the examples that we've done before. So let's go ahead and start swapping it out. We have this view model. Let's swap out the list with a paged list. And then we go back to our DAO. Now what we want to do here is we want to ask our DAO, hey, can you give me a live data of a paged list? But there's actually an issue with this. So if we look over at what the data looks like on the database side, you could imagine paging this in one way, and you could imagine paging this in a different way. There's actually some interesting decision here. Are you showing really large items? Are you showing tiny items where you want to have a lot of data paged at once? Well, the page size really needs to be configurable to, serve every app's needs. So instead, Room can produce this data source class that backs a page list, and that way the page list can access it and say, give me items 6 through 12, and load those data directly into the page list. Now, because we say that we want multiple of them, though, remember that we want something that's observable, so we just wrap that in a factory. Every time that we need a new page list out of the database, we create a new data source. All right, so instead of the live data of page list, what the user DAO provides us here is a data source factory keyed off of integer because we're using positions. So we go back to our view model here and define how are we going to load this data. Well, it's not much code. We just say get the data source factory that we've just declared in our user DAO and use this live page list builder class from the library to create a live data. The minimum amount of data that you need to pass here is page size, and here we're passing 30. That's it. Now you have a live data of page list. So now all of the repository side changes are done. The view model's updated. Let's go to the activity. So now we were using list adapter before. Well, simply you change this into a paged list adapter. A paged list adapter is the exact same thing as list adapter. It just happens to handle the loading of pages as content is internally updating in those page lists. So if we look at how we'd actually implement this list adapter, though, we'd have to switch over to the new page list adapter and use the exact same diff callback. We don't have to change any code there. The only thing that changes as part of implementing this on the adapter side is that the user object becomes nullable. And we'll get into why in just a little bit. So let's go through how you can do further configuration, because we don't stop at just page size. So the code that we showed before of creating a live page list builder, you can simply just pass a minimum page size, and that's the minimum amount of data that you need to pass. But you can also create a configuration object where you can declare more. So one thing that you might want to do is set an initial load size hint. And what this does is it requests that the initial load is larger to make that initial load avoid initial page fetches immediately after you've fetched it. Another thing that you can change is prefetch distance. By default, this is the page size, but you can configure this if you know that your data source is higher or lower latency. You can also control placeholders, which are an important part of this library. So let's start talking about those. So placeholders false is kind of the default paging that you might have, the expectation that you might have, where typically you load the first page, the recycler view has access to the number of items that you've loaded, and you see, well, you have a big scroll bar, right? The user can scroll through it, and once they get to the bottom, there's no more data. Once the page loads, the scroll bar jumps, and the user is able to scroll forward. So we also support a completely different type of paging here that presents this differently. If you ask for placeholders, and this is the default in the library, we will present your lists like this. You notice here that the scroll bar is a little bit smaller, and that's because we're presenting the entire data set to the recycler view immediately. That scroll bar won't jump while we're scrolling. As the user scrolls down, you see that there are unloaded items, and those are presented as nulls in the adapter. These items, as the data eventually loads, display, and you'll get a nice animation for that. So let's talk about placeholders, because they don't work everywhere, but we think that they're really useful in a lot of cases. So one of the big positives of them is that the user can scroll past what's loaded. The user doesn't have to hit a block at the very end because you don't have any more data yet. The scroll bar looks correct instantly, and also, this is very important, you can use fast scrollers very easily because you have the entire data set presented to the recycler view, so you can jump anywhere. And then another nice feature is that you don't have to implement a loading spinner at the bottom because the users can see the placeholder. They can see that there's like a gray icon instead of a user icon and know that that item is still loading. There are some downsides, though, of placeholders. First of all, it's pretty important that your items stay the same size. If you can't guess what the item height is going to be before you have content, for instance, if you have, say, a social media post with arbitrary amount of text, the crossfade animation doesn't look great. Additionally, your adapter has to be able to handle null items, so that's a little bit more code that you have to write to say, if this item doesn't exist, pass an empty string to the text view, that kind of thing. And then your data source has to be able to count items. Now, Room can count items out of the box, but if you're using something that is loading data from, say, the network, your backend may not be able to provide a precise count. So we've been talking a lot about our live data thus far, but as Yigit introduced at the beginning, we also want to support our RX Java developers. So instead of producing a live data, you may want to produce, say, an observable, and we provide the class RX Page List Builder to do exactly that. So you can change the return type here, use an RX Page List Builder, and then just specifically request an observable or a flowable out of it, and you get all the same behavior. You can use all the same code that we were showing before with a little bit of change to switch to RX observation. Now let's go under the hood, because we've shown how small of a code change this can be to switch to the paging library, but how does that work underneath? OK, so here on the left, you have the repository that represents the data loading portion of your application. And then on the right, you have the view model, which is how it communicates to the UI. So inside the repository, we want to build the source for this live data. We want to produce something that will push updates to the UI. So when you call livePageListBuilder.build, we create not only a live data that can be used to funnel information to the UI, but the producer side as well. Once someone starts observing that live data, we will create a new page list, because that's the way that we start passing information down this pipeline. And to do that, we create a new data source out of the factory that Room is able to produce. Now, to pass this page list over, though, we don't want to send an empty list. If the UI can avoid it, we'd really like to load data first. And so we do that on a background thread, initialize that data, and create a page list out of it. And here you can see at the very beginning, the first page list that we produce has data only loaded at the very front. We can send that over to the UI thread. And then if you remember, our submit list call on page list adapter submits this to the adapter, and the adapter can start immediately presenting those items. Now, as the user scrolls, though, we might need to load more data. So the page list internally will trigger a data load from its data source and append that data directly to the page list. Now, the crossfade animation occurs because we have signaled the recycler view that these new items are updated again. But what happens when a content update occurs? So if the database says, oh, this table has been invalidated, something has changed, we immediately stop loading from the data source. We invalidate it. So let's look at what happens in order to start pushing those updates, though, from the other side. So on the other side of things, we can see, oh, well, the database had an item added to it. That's why we invalidated the previous data source. And at the same time, the producer side is listening to this signal to know, I need to produce a new page list. So we use this signal to create a new data source so that we can create a new page list to send over. And when we load the initial data for that, though, we're careful to initialize that based upon the loading position that was signaled by the adapter. So the user is partially scrolled down, so let's center our load around where the user is. We send that over to the UI. And now we submit list again. But because these are two different lists, and we really don't want to call notify dataset changed, what happens is that we compute an asynchronous diff on a background thread, just like with list adapter, as Yigit mentioned earlier. Once that diff is computed, we pass that diff result into the recycler view and swap the new page list in. Immediately, you get a new item showing up, a new animation for that, and we only have to do the minimal amount of UI work to bind and show the new item. So fundamentally, under the hood, we do a lot of trickery to make this work, but from the outside, we try and make it look as close as possible to a live data of a list, because this is a really nice experience. It lets you keep your UI really, really simple and avoid all of the information about paging on that side, and let you configure and construct your flow in one place from the repository. The page list adapter is able to handle both the new page lists as they flow in, and also the internal updates of the page list as it loads.
Thank you. OK, let's talk about data sources. So we mentioned that page list is a list implementation that works with a data source. And we have different types of data sources. You can have a positional data source, an item keyed data source, and a page keyed data source. OK, let's start with the positional data source. If you have an application like the context application on Android, where you have the data locally, but user may want to jump into arbitrary positions, positional data source is your best option. This is actually what Room uses behind the scenes. So if you have a data source or a UI like that, you extend this positional data source class, and you specify the type of items. But to better understand how this data source behaves, let's look at an example. So we have the UI here. We'll just zoom out, go to the bird's eye view, and we have our data source on the right, backed by a list. The very first time you come to the recycler view, Pages will call this load initial method on the data source, pass the start position, a page size, and a load size, initial load size, which is usually larger than the page size because you want to have more items at the beginning, and whether placeholders are enabled or not. In this example, we just assume placeholders are enabled. So our data source will return the data, tell us where that data starts, and it will give us the total number of items in the data source. Based on that, we'll start displaying the data, but we'll also display the placeholders so that the size of the page list is equal to the total number of items in the data source. Now, user can start scrolling. As soon as user starts scrolling, Pages will realize that it's going to run out of data, and it's going to call this load range method on the positional data source, pass it the start position of the first item is missing, and a page size, and get the new data appended to the list. So imagine in this case, user uses the fast scroller and jumps into an arbitrary position where we didn't have the data yet. When this happens, it will call the data source load range position with a position slightly above recycler view and load that page so that we can display it to the user. This is why positional data source is really good if user can jump into arbitrary positions. You never block them. Let's say something has happened in the database, data has been invalidated, so we'll get a new data source. So each data source represents a snapshot of the data. So we get this new one, we'll create a new page list for it. And we'll load the initial page from this data source based on where user is in the previous one. We'll bring this one, as always, on a background thread. We will calculate the difference between these two lists and update the recycler view with the correct animations. Second one is the item keyed data source. So imagine you have some data like a list of names. If you look at a page out of this, you can identify the items before this page by using the first item in the list, and the next page by using the last item in the list. Basically, every item can identify a page after or before it. If your data source is like that, you should implement the item keyed data source class. You provide a key type. In this case, we are using names, so string, and the item type in the list. OK, let's look at an example. So first time you come to the recycler view, it'll call the load initial method, pass the initial key, which is null, because we don't have it, and request the load size, and whether placeholders are enabled or not. We'll just assume they're not enabled in this example. So data source will only return this data, it's not going to count it because there's no placeholders. So start displaying it. As soon as user starts scrolling, we will extract a key from the last item we have and call the data source load after method to load another page. Similarly, as user keeps scrolling, just extracts a key and then loads another page the same way. Now at this point, let's say this data was coming from the database. Similarly, something has changed, so we lost that data source. It's been invalidated. We'll get a new data source. When we create the new page list for this data source, we are going to extract a key from one of the items that's currently visible in the recycler view closer to the top and load a page from this new data source. And we get that page. We understand these are page lists. We will calculate the diff and update the UI with the correct animations. Now, we don't have the data on top anymore. So if user tries to scroll up, we need more data. Same thing. You just extract the key from the first item, call load before method on the data source. Just get that page, prepend it to the page list, and now user can scroll upwards. So it's always lazy, always reactive. Third one is the PagedKeyedDataSource. Now, this is a very common way of paging, especially on the server-side APIs. So your client sends a request, and when the response comes from the server, it includes the data. It also includes pointers for the next and previous keys. GitHub API works this way. Reddit API works this way. It's very common. So if you have a data source like that, you should implement the PagedKeyedDataSource, specify the type of your keys that you use in the pointers, and the item type. OK, let's look at an example. First time user comes to the UI, we call load initial. We give it a size, and we ask whether placeholders are enabled or not. They're usually disabled because your server doesn't give you an accurate count. So we'll just assume they're disabled. Easier. And then the data source returns the data, but it also gives us pointers for the previous key and the next page key. And then we start displaying it. If user scrolls, we need more content, so we are going to call the load after method, use the key that was returned in the previous request to get the next page from the data source. Now, this next page comes with a field called adjacent page key. So it always tells, OK, what is the next page in this direction? It's literally like a linked list of pages. Once you take that, user can scroll more. Now, a difference in this data source is how we handle invalidation. Imagine user hit the refresh button on the screen, data source is invalidated. We'll get a new data source. But in the load initial method, there is no key anymore. This is because I mentioned it's like a linked list. So if the previous list is invalid, links in that list doesn't mean anything. So you always need to load the very first page again and display it in the UI. This is usually not a problem in practice because you only do this if user does swipe the refresh, so they're already on top of the list. OK. Yeah.
All right, so you talked through what we might see implementing a data source. But what happens when we want to load from multiple sources at once? So a database plus network solution, these two components can work really nicely together when the database acts as a cache for the network. You can page from your backend that you have with all the benefits of the local cache. You can have a really nice offline support. You can resume quickly if the application has been killed and restarted. And you can minimize network traffic by taking advantage of data that's already on device. So let's look at how this might look compared to what we were showing before with a single source of data. So how does the network fit into this system? So one way that we could do this is we could basically say, well, the network is my source of data when I'm connected, and the database is my source when I'm not. So if I'm connected, then I page data from the network, and if I'm not, I page data from the database. The one problem there is that you don't have anything storing data in your database even when you're loading a network, but it's pretty easy. As a side effect of loading from the network, you can just store in the database. And there, you have paging from both. However, this has a couple of really big problems that are important to discuss. So this switching model has the first problem, that this connected state is really oversimplifying. In reality, individual requests to your servers can succeed and fail, and a user that's connected like 20%, some of the packets go through, that doesn't really fit really nicely into this model. The other big problem is that we're not using local data when it's present. So let's go about looking at a different way to do this. So what if instead we just monitor the database and use that as our local single source of truth? What we can do then is we can say, well, the only time that I need to load data is when the database tells me that it's out of data. I can use that as a signal to load more data from the network, store it into the database, and then I have my entire solution built. I just load data when I need to, but I can present only the database, which makes things a lot simpler. So we get the benefits of consistent data presentation. We have a similarly simple process, but importantly, this gracefully degrades on failures. If your user is in that 20% connected state, you can still present all of the data that you have locally and try and fetch or potentially retry when the network is around. So potentially you might say, well, this doesn't keep my data fresh. And an easy way to work around that is to just say, whenever anyone starts observing this stream of data, we start a new fetch. We see if we need to refresh our content. And that's especially important usually when you have frequently updating data. So in that proposed model here that we saw, we need an out-of-data signal from the database, because the rest of that we've basically already built in the first few slides. So when we have that signal, we can trigger loads from the network directly into the database, and the UI doesn't have to enter into any of that. So paging built exactly this signal for exactly this reason, and we call that the boundary callback. So let's go ahead and look at what that might look like. So the first most important part of the boundary callback that you implement is that you pass it two different, you'll want to provide it two different sources of data, the database and the network, because that's its job. So the first, the important callback that we have here is on item in loaded, and this signifies the last item in the database has been loaded from the paged list, and if there's more from the network, it's time to load it. So the first thing that we do in response to this is that we, over on a network thread, we can request our service, hey, give me more data. And in this particular case, we're using the item at the end to feed which data we need more of, because we're in an item keyed case similar to the item keyed data source that you saw before. Now, if that request is successful, we simply jump over to the database thread, insert that data that we loaded from the response into the database, and we're basically done. We've connected that signal that we needed, and now we've added network to something that was purely database. Now, the one other trick that you need to be aware of, though, is that it's possible when the database is being invalidated locally for multiple at-end signals to trigger. So what you can do is you can just protect this with a simple Boolean to say, if I'm already loading, don't try. And then we can reset that at the end. So using this boundary callback is pretty simple. You can just add this back into your live page list builder or to your RX page list builder, and then that gives you the database plus network solution all isolated in that one callback. So let's talk about what the paging library is. So the paging library provides paging from database, network, and importantly, both, as we just saw. And it can load that data directly into RecyclerView. It extends this live data of list, this observable list pattern that we really like because it keeps our UI incredibly simple, and it lets us contain all of the complex logic on one side. It's configurable. We have configurable load size, prefetch, and placeholders. And it integrates directly with Room, with live data, and with RX. The Paging 1.0 was just released, and so please give it a try. Take it for a spin.
Good. Hi, that was a lot of information we know. So where to go next? Well, we have extensive documentation on developerandroid.com, so you can just read We provide more details and more samples there. We have an amazing code lab. You can just check it out in the code lab area, or you can try it online. We also have samples on GitHub where we implement different data sources using Reddit API or a different looks in Docker database, and you can compare and contrast the behavior of different data sources. And you can also see how you could handle things like errors, retries. We have all of it there. But if you've been sitting here for the last 30 minutes and wondering whether these two guys never heard about Cursor and it's built in paging, rest assured we did hear about that. So that's actually what we wanted to use initially when we started this project, because we already have Cursor adapters. Cursor already takes care of all the work, right? Wrong. So we realized it is very unpredictable and inefficient if your cursor becomes large. So especially if you're in your application currently, if you're using cursor for lazy loading, be very careful. Room and paging together avoids this problem because we create much smaller queries, not to rely on the paging behavior of cursor. Now, it's a very complex topic, but Chris wrote an amazing blog post about this that you can watch in that link, and we will post this URL after the talk. It's amazing, but TLDR, cursors paging is not the right way to do paging. We did it wrong. We hopefully fixed it this time.
Did it wrong 10 years ago, at least.
10 years ago. It's not me. OK. OK. So paging is part of Jetpack, our new initiative to accelerate Android development. We had great many talks at this I/O. This was the last one. So please, if you were not able to attend those sessions, check them on YouTube. Everything is recorded. And you can also learn more about Jetpack on our website and provide us feedback. Thank you.